Hi, welcome back to my channel. Well, in this video I'll be doing a demonstration regarding various forms of t-test because t-test forms the foundation of testing of hypothesis when we are comparing samples in terms of means, and whenever we are comparing samples in terms of mean, then there's an important assumption of normality and we have to check it out first. Then we have to proceed all these various forms of t-test, whether it is one sample t-test, whether it is two sample equal or unequal variances, or whether we have a correlated type of t-test which is known as peer t-test. So we'll be starting with an example of one sample t-test. For that we have an example wherein a vegetable expert has released a new variety of vegetable which is expected to give a yield of 14.5 quintals per hectare. This variety is tested on 12 randomly selected farmers field. The yield in quintals for per hectare are recorded as like this. So this data is already available in my Excel spreadsheet. Then I will be copying it or importing this by means of a traditional way of importing the data, that is simply highlight this data and copy. Then I'll be using this read.table option function here, and I'll be giving the name to this data set as veg, which stands for the vegetable. Then simply I will highlight this and click on this run. So we have a data set. Then I will attach this data set here. Then the important thing is that I have to see whether our data is normally distributed or not. Only then I can proceed with this parametric one sample t-test. For that I'll be using this shapiro.test test. For that we have a default function, that is shapiro.test. Then I'll press on this enter. So we have a evidence with respect to the p-value because it has a null hypothesis that the data is normally distributed. So we are expecting a non-significant p-value much higher than the standard 0.05 value. Or we can test it graphically also by using ggqqplot. For that, make sure that this library is already recalled here. So we'll be using this function here. Then click on this run. So we have a graphical visualization and we can see all these data points are very close to this solid line and they are within the band, within this gray band. That means we're good to go to perform one sample parametric t-test. For that we'll be using this set.seed function, and for that we'll be using this gghistostats which utilize some arguments, that is the name of the data set, then followed by the name of the study variable, and we'll be using some titles to also, since in this case the yield is in quintals per hectare. And this is very important because from Shapiro will test and ggplot the data is normally distributed, so we have to type here parametric, otherwise we will write non-parametric here, and we'll be having a certain kind of a normal curve or we'll be expecting a histogram type of a plot with some good statistical details. So simply we will highlight all this, then click on this enter. So we'll be having a plot here with some good statistical details. Since the total number of observations are 12 and the degrees of freedom for one sample t-test is n-1, that is 12 minus 1 is 11. So this is the t value, and here the p value is evident that this t is different from the 0, or we can say the far away from the 0, or we can say we are having an evidence to reject the hypothesis. That means the claim that he has given is not true, and we have some another statistics here, that is hg, which actually estimates the standardized difference among the means, but this is a standardized one. But for that we have another alternative. We can use this bias factor, which actually tests this hypothesis or gives a substantial evidence against this 0, that is null hypothesis, as well as alternative hypothesis. So this is the way how we can perform the one sample t-test utilizing ggstatsplot 2. Now quickly moving to another test, that is two sample t-test. For that we have an example, two varieties of potato which has got two varieties x and y. It yielded some tubes which are shown here. Does the mean number of potatoes or the average number of potatoes of variety x is significantly? That means we have two samples, variety x and variety v, and we have to test them in with respect to this yield, whether they are significantly different from each other. For that we have a data set and we using the same procedure here. Simply we will copy paste this. This is the traditional way. Otherwise we have an option of import data set also. Then we'll use this attach option also here, that is attach potato. then we have to use a library, that is library car, because this is very important, because we have to see whether we are able to perform a two sample t-test with equal or unequal variance. For that we have to test the homogeneity of variance using the Levin's test. For that we have to use the arguments, that is the response variable with respect to the different categories. Since we have only two categories and the name of the data set, then we will press on this and click on this enter. So here you can see the p-value is again non-significant, which again says that these two are homogeneous in nature. So we are expecting a homogeneity with respect to the variances. So we have to use the traditional students t-test. For this we don't need this Welch t-test here, so we'll be again using this set.seed function. Then gg between stats is used for two sample t-tests with equal variances, because it is evident from this Levin's test that there is a homogeneity of variance. Then the same thing, the name of the data. On x-axis we have to give the categorical variable, since we have two varieties, and on y-axis our study variable and type, since we are using the parametric, which is evident already. We are using this parametric test. Then we have to use this var dot equal is equal to true, because it is evident from the Levin's test that there is a homogeneity of variance. Then simply what we will do, we will run this, and we'll be having a plot, a wonderful plot with some good statistical detail. So again we have the students t-test here value, we have a p-value which is less than 0.05. that means both these varieties with a mean of 2.26 and 2.27, this is significantly different in terms of yield. So we have evidence to reject the null hypothesis, and we have g value and bias factor also. So very quickly I'll be moving to the another thing, that here if I will write here var dot equal to false, since in the first thing we have, in the first option we have assumed that we have tested it that there is a homogeneity of variance, that's why we type it here var dot is equal to true. If this test would have been significant, then we have to use this option var dot equal to false. Suppose if we will run this, let us see what will happen, what kind of plot we'll be having. So here it is not students t-test, it is Welch t-test. So we have two forms of t-test. One is which assumes the variances are equal, that is known as students t-test, and this test is used when we are having the unequal variances, which has to be verified by means of this Levin's test. So the final one is peer t-test, which is used when we have correlated samples or before and after experiments where the subject is same. For that we have an example here, the average number of seeds per pod in a P were determined from the top and bottom flowers in 10 plants. Test whether there is a significant difference between top and, so we have the same subject, only we have two things, top and bottom. We have to see whether there is a significant difference between top and bottom flowers with respect to the average number of seeds. So for that we have a data set, one which is available on my this Excel spreadsheet. So this is the data set, and we'll be doing the same step, copying it in the traditional way. Then we'll be using this read.table function. The name of this data set is P. Then I will press on this enter, and again I'll be using this function attach, which I always prefer. Then within this I will write this P. So I will press click on this enter. For that I have to use this option gg within stats, then the name of the data set, then x categorical variable, because we have two types here, top and bottom, and the name of the response variable or the study variable or the variable of interest, and I have to type here parametric, since I am using a parametric one. So again I'll be highlighting all these, then click on this run option. So we'll be having a plot with some statistical. Here we have the students t-test, which is 1.2, and this is non-significant, here it is not significant. So both these top and bottom flowers with respect to the average number of seeds, they are not significantly different from each other, so we don't have evidence to reject this hypothesis. So this is the way how we can perform the various forms of t-test utilizing this wonderful library, that is ggstatsplot 2, and we can have some plots which are we can fetch some good publication, or we can say the publication ready plots. These plots are quite attractive, and they can be easily understood. And these plots, they actually utilize the box form, and these are called the notched box plots. So if you are interested to perform the one sample t-test or two sample with equal or unequal t-test or peer t-test, for that this library ggstatsplot is highly recommended. So I hope that you will like this video. If you have any questions or any comments, please post on the comment section below. Thank you very much.